All right, demo E2. This question is adapted from part of a homework assignment I gave in a previous semester. So we're going to walk through a Monopoly using some math. Okay, so we're asked about golden snitches, which is part of the game of Quidditch. It's really difficult to manufacture a snitch for sort of technical specification reasons. So everyone buys their snitches from Ruffle Bottoms, which is just a sporting goods manufacturer. So we're given a demand curve for golden snitches, which is a pretty simple little representation here. And we're told that the marginal cost of producing each snitch is constant at 10 galleons. So this is going to be a flat line for marginal cost. And we're told there are no fixed costs. So I'm going to tell you a little bit later why this is important, that there are no fixed costs. It's not a very representative assumption here that there are no fixed costs. Most production has some fixed cost in the short run. But this makes our lives a little bit easier for solving at least the core question. And I'll show you why. We're given the marginal revenue curve for the snitch, which is just 100 minus 2q. And then we're supposed to use one graph to answer parts A through C. All right. So this is the graph. We have a downward sloping demand curve given to us by Q is equal to 100 minus Q. And we have our marginal revenue curve. We also have our marginal cost curve, which is constant at 10. And it turns out with a constant marginal cost curve and no fixed costs, marginal cost is equal to average total cost. And this is a pretty unusual scenario here. It makes our lives a lot easier, so I like to use this example when dealing with monopolies. Mathematically, this is a little bit simpler than a lot of other cases. When there are no fixed costs, the difference between average total cost and average variable cost is 0. When there are no fixed costs, every cost is variable. And when marginal cost is constant, average variable cost is constant, which means average total cost is also constant. And it's constant at marginal cost. And the intuition here is that every time we add one quantity, we're adding a constant number to our costs. So we add 10, we add 10 more, we add 10 more. So the increase in total cost is constant, just a constant 10. So every time we add to cost by 10, we also divide by one more. So our quantity is going up by 1, which means that average total cost is constant. That's the idea here. So to solve for the monopolist problem, we simply intersect marginal revenue with marginal cost, which gives us our Q star. We run Q star up until it hits the demand curve, and then we find the price that corresponds. To find profit, we simply look at average total cost at our Q star, and we take the difference between price and that average total cost, which in this case is 10. So the vertical here is 45. So I've plotted the numbers here, but let's walk through how we actually solve this. So for part A, we're asked about quantity. What's the profit maximizing number of snitches Ruffle Bottom should sell? And we do this simply by intersecting marginal revenue with marginal cost. This is when adding an additional quantity would make no difference to our profit. Beyond this point, we would be reducing our profit, and before this point, we would be missing out on some profit we could have had. So we set 10 equal to 100 minus 2q. And from there, we just simplify. So we have 2q is equal to 90, which simply gives us q is equal to 45. And then we just use the notation we're using in this question, which is q star is equal to 45. So for the second part, we're asked about price. What's the price Ruffle Bottom should charge per snitch? We plug q star into the demand curve. We simply run q star up until it hits the demand curve. And to do that, we have our demand curve P is equal to 100 minus Q. We take our 45 from the first part of the question, plug it in, and that gives us a price of 55. So we just put that on the graph here. And then part C is about profit. So we simply look at the price minus the average total cost, which is 10. We multiply it by the base, which is 45. So that just comes out to be 45 squared. And we can just plot that with everything else. Okay, so that's pretty straightforward math here. The last question in demo 2 is about a lump sum tax. So it turns out the ministry, realized that Ruffle Bottom was capturing a great deal of welfare from the Quidditch world. Remember, we have this large deadweight loss. We weren't asked to calculate it here, but we could have done it pretty straightforwardly. So they realize this and decide to impose a fixed cost on the seller. So we want to actually have a different average total cost from marginal cost. So we're adding some fixed cost, where before we said marginal cost is equal to average total cost. So here we actually do have some fixed cost, which means average total cost will sit above marginal cost. But it turns out adding fixed cost to this system doesn't actually change anything about the firm's solution. Marginal cost doesn't change, and marginal revenue doesn't change. So the solution to the firm's problem, Q star and P star, also doesn't change. The only thing that changes is that average total cost is now higher. So where profit before was this entire rectangle, now profit is just this rectangle up here. We run Q star until it hits ATC, and then we find the difference between price and that ATC on the vertical, and then we multiply that by the base of Q star. So profits go down, but quantity, importantly, does not change. We haven't impacted the solution to the firm's problem. Okay, so that's sort of the summary here. This is not a question I would ask with math because of the complexity of this new average total cost curve. But we can do it graphically. We certainly know what's happening with the graph. All right, I'll leave it here.